stoichiometry calculation. It's about finding the proportions in which different elements or compounds react. Let's have a look at different examples based on stoichiometry. How many grams of silver chromate will precipitate when 200 ml of 0.5 silver nitrate are added to 100 ml of 0.3 molarity potassium chromate? So the first thing you do is you get the equations. You put a balanced equation. You write down the equation first, and the next thing is you make sure you write down all the given variables. In this case here, the concentration, which is 0.5 molarity, and the volume, which is 0.2. And the next thing you do is just find the number of moles using the concept C equals to N over V, where N, which is the moles, number of moles. So N equals N value is C times V. And the mole ratio, so we found the number of silver nitrate, which is 0.1 moles, and the mole ratio between silver nitrate and silver chromate is 1 to 2. So you have 1 there, so the coefficient, 1 there again, you have 2 there, so it's 2 to 1 mole ratio. So to find the number of moles of silver chromate, we divide by 2. And to find the mass of a molar mass, so to find the mass, which is M lowercase, so molar mass here, and that is the mass of silver chromate that will precipitate when these two soluble salts are mixed. Let's have a look at another example based on this concept. How many ml of 0.28 m barium nitrate are required to precipitate barium sulfate, all the sulfate ions from the 25 ml of 0.35 m aluminium sulfate. So the first thing we do is, again, we have to make sure we write the equation itself. So we are mixing barium nitrate. The first step is just to make sure you write down the equation. So barium nitrate, which is a soluble salt, reacted with aluminium sulfate to give barium sulfate, which is a soluble salt, plus aluminium nitrate, which is insoluble salt. And just to make sure you balance the equation as it is, so just put a question mark the one you ask, the one that was asked. So in this case here, so we have been given the concentration of barium nitrate, I should say, M, and it's AQ, it's a solution. That's AQ, that is a precipitate, that's solid. That's another AQ. Alright, so the volume we're trying to find out the volume. Put a question mark, and we also have the volume of aluminium sulfate, the concentration of the aluminium sulfate is 0.35. And the volume is, just put it in liters, 25/1000. That's the liters. So we need to find out the moles of aluminium sulfate which gives us moles. And the next thing we need to find out is the number of the mole ratio. So the mole ratio is 1 to 3. So we need to find out the number of moles of mole ratio. Mole ratio is 3 to 1. So the number in front of the compound. So we have 3 there, we have 1 there, 3 there, we have 2 there. So the barium sulfate, barium nitrate I should say, barium nitrate so the volume will be which is in milliliters, just multiply by 1000. So that's 93.75 milliliters. Alright, let's have a look at another example. So this time we are finding the volume of hydrochloric acid. What volume of hydrochloric acid, which is 0.496 concentration, is required to neutralize 20 ml of 8.09 concentration of sodium hydroxide. So the first thing we do is we get the equation right. So let's get our equation written down. It's always a good idea to write all the given variables. Salt and water is produced. Salt and water produced. In this case, it's 2 there. 2 there. That's enough. I think that is balanced. Yeah, it is balanced. So that means we just don't need that 2 there. I don't need that 2 either. Alright, so the next thing we do is C1, which is the first concentration, is 0.496 M. V1 we don't know, we just want to find out. So C2 been given as to be and V2. So write down all the given variables, and the next thing you do is you put a question mark on what the question is asking. In this case here, we need to find out the volume of the hydrochloric acid. And that's what we get. That's the volume of hydrochloric acid required to neutralize that amount of sodium hydroxide. All right, let's have a look at one more example. 60 ml of 0.322 concentration of potassium iodide are combined with 20 ml of 0.53 concentration of lead 2 nitrate. How many grams of lead 2 iodide will precipitate? So again, we need to write the equation. That's the first thing we have to do. Potassium iodide and that is the precipitate that has been formed, potassium iodide. And we need to find out the number of moles of potassium iodide. And the next thing we need to find out is the mole ratio. We have 2 there, 1 there, 2 and 1 there. So the mole ratio is 2 to 1 between potassium iodide to 1 lead iodide, 2 to 1, and so therefore we divide this by 2. So moles lead 2 iodide is half of that. then we need to multiply. We can just do the whole lot in one go, to be honest. We're just going to get the mass of lead 2 iodide times the molar mass. The molar mass of lead 2 iodide is 461. You get it from the periodic table, and that gives us, after you multiply all those, 4.45 grams of lead 2 iodide. So therefore 4.45 grams of lead 2 iodide has precipitated in that reaction.